was filing away the PDF document that I printed off for the service diagram of the VC15, I did notice there was a question mark in the on the plan, and this turned out to be a pop-up. And when I hovered over the pop-up, it gave the service details that to set bias to minus 11.5 volts on resistors R48 and R49. Now R48 and R49 are on the other side of the board and hidden away. However, one side goes to ground and the other side goes to pin 2. And on the diagrams you can quite clearly see that they're attached to solder pads 19 and 20. So here we have solder pad 20 and here we have solder pad 19, and on the other side of this is a surface mount resistor on the back of the board. Now I say these wires coming out of the solder pads go to pin 2 on the valve, so theoretically I need to attach a wire to pin 2, then to ground, and I get the bias voltage measurement at pin 2. Now it says to set it to 11.5. When I received the amp, I don't believe it had been worked on too much. There are some signs inside of it having some remedial work, but not an extensive amount, and I said it was actually running quite cold, so I adjusted up the bias. So what I'm going to do now, and this is the settings that this is my 60%, this is what I achieved. If I then measure at pin 2, so although I was setting it with the bias meters for milliamps, what I'm going to do now is use the bias pot here to set these voltages to minus 11.5, and we'll then go through and check the bias, the method I would normally use, preferred method being voltage drop across the primary output transformer. So I use that method, and then we'll see what the voltage is, or what the current dissipation is, setting it to the preferred setting of Laney. So we're going to go for 11.5 on here. That's probably about as close as I'm going to be able to get to it. So 11.4 on one side, 11.53 on the other, so one under, one slightly over. So now what we'll do is we'll switch the amp off. I'll disconnect the wires in there and I'll set up for measuring, as I would do, setting the bias via the output transformer method. Now I've already measured the resistance of the primary windings on the output transformer, and I got on one side 99.4. This is the voltage going to the, what I call the outer tube, and I got a 110.4 ohms on the primary winding going to the inner side tube. Now what I'm going to do is measure the voltage drop across the primary windings. So attaching one to the centre tap and other wire it's going to the output to the inside tube. We get I'm going to call that 2.23, and on the other side 1.98. Okay, so we have the impedance of the output, primary winding of the output transformer. We have the voltage drop across the windings. So if I divide the voltage by the impedance, that will give us the current at the valve in millivolts. So what we need then is the plate voltage. Now that's between pin 3 and 7. Now they're wired in parallel, so I'll get the same reading no matter which valve I take. But what we can do is go from one valve and the other, that way it just doesn't get so cramped in the inside when I'm trying to fit the pins on. And there we have I'm going to call that 299. Okay. So we've set the bias via the bias meter using pin 2 and the Laney specified minus 11.5 volts, or as near as we can get to it. Switch this off now, we don't need that. So now we can do all the calculations. So for the what I would call the outer tube, we have a voltage of 1.98. I'll divide that by 99.4, the measurement, the impedance I got before I started, and that gives us, near as darn it, 0.1991. So we'll call that we'll call that 2 millivolts, or rather 20 millivolts. And on the other side we have .24 divided by 110.4 gives us 2.02, or 0.02 millivolts. So we've got the same on more or less on both sides there. Now we have a plate to cathode voltage of 299 volts. So if we then multiply those two together, so we go 0.02 times 299 equals 5.98, and 5.98. So we can call that 6 watts of dissipation on each valve. Now the valves will handle 12 watts of dissipation. Now So we've got a dissipation here of 50%, which is considered on the cool side. An average would be what I tried to set it to initially at 60%, which would give 24 milliamps, and you can have a maximum of 70% of, this is a class AB fixed amp, so 28 milliamps will give you a 70% dissipation. So although we've used the Laney preferred measurement or setting method, it does actually set the bias quite cool, but presumably this is a choice that Laney decided to make. It does extend the valve life, it does give a cleaner, harder sound. So that's about it for this one. An alternative way of setting the bias on a Laney Mark 1 VC15 110. I hope you found that instructive. If you have one of these amps, be aware, of course, I mean 300 and nearly 300 volts DC in there, so higher in other places as well, so be aware of that if you're delving inside one of these amps. And if you're at all unsure, please don't do it. Take it to somebody who's happy to delve inside and take the risk for you. So I don't know whether you found that instructive or not, but that's a way of, as I say, setting the bias to Laney's specification for this amplifier without having the need for anything more than a normal household multimeter, just setting the measurements on pin 2 of the 2 output valves and a suitable earthing point, and then adjusting the bias pot to achieve minus 11.5 volts. Goodbye.